Let's go. I really got the feeling today that everything is going my way. Now this is what I'm talking about. Every time I see your smile, it makes me shout. Let's go! Let's go! Nothing's gonna stop us today. Get on the bus or get out the way. We're cruising with the radio on. So turn it up to 10. Here comes our favorite song. Let's go! Let's go! Let's go! Let's go!
Yep, good morning, good afternoon, good evening, good dawn, good whatever it is, wherever you find yourself. Welcome to another thrilling, interesting, head scratching, mind blowing, exciting episode of the IoT Tuesday show. I'm yours truly, Samuel Adranying. It's another day for us to break things down, think and build something great, just to have fun, to learn, and to get ourselves abreast of what's happening out there. Before we get into the show for today, if you have been following, last week we started a series on building the Ballot box tracking system. We talked about the various options. I put out a poll asking whether you want us to use a pre-made off-the-shelf solution or you wanted us to, build something from scratch and use. So the winner of that poll was you wanted us to build something from scratch. Now, when we come back, I'm going to walk you through some, ideas I put together pertaining to building it from scratch. So don't go anywhere. Stick and stay. I will be right back. Awesome. We are back. We're back. So, last week, as mentioned, we started a series on building our ballot box tracking system. All right. And I showed, we talked about the reason, talked about the potential, the tools, the technology, all that. And I posed a question back that whether you wanted us to use an off-shelf solution or you wanted us to build from scratch. So, before I get into it, as always, I want to tell about a few things happening, and then we'll jump into, building it. So let me get into this. And yep, so before we get started, you need to know about the upcoming meetup that the Accra.net user group, myself and Frank Odum and other interesting guys in there are organizing. It is a chat with Matt, so he's going to talk about, C#, all the goodness, all the fun stuff happening in the world of C#. You can ask your questions and all that. Go to the link, bit.ly. Actually, let me put this here. So bit.ly /3GZNQ, a big Z, and a C. Go to this link, sign up, register for that meetup, talk to Matt, ask questions, have a very interesting and wonderful time. All right. With that said, let's move to the next thing. It is the MCT West Africa Cloud Bootcamp. So yes, all our MCTs across West Africa are coming up with a massive event. It's 8 days, 64 sections, 64 speakers, 4 workshops happening virtually on Microsoft Teams. And we'll be talking about stuff from Azure to .NET to M365 to the Power Platform. Interesting sessions. Make sure you register down there. bit.ly MCT WAC B20. Make sure you also register there as well, so that you can join us for the fun and the interesting times. So that is the second thing. The third thing is happening from September 9 to 10. It is the virtual event for the Dynamics Con for the community, built by the community. Yes, yes, truly. I will be talking about interfacing IoT with the Power Platform. So make a date with me. If you miss a couple of my sessions on IoT and the Power Platform, this is another opportunity for you to get me. You don't have to miss this. So let's get this rolling. All right. So what else? These are the three top things I want you to pay particular attention to, so you can go to dynamicscon.com and then you register. All right. So with all those things out of the way, let's get back to action. So you spoke, I listened. You said we should build it from scratch. Now, ideally, if we're supposed to go to market with this, there are a lot of options that we could explore in going to market like rapidly. And during the whole of last week, I went out to look for other options, and then so there's this cool thing. Well, it's from Particle, right? So particle.io. Let's actually go here again. So particle.io actually released, all right, how do you call it, like released another board, or so to speak, that's called a tracker SOM, that actually pretty much has, again, all the things we're looking at in a much even smaller form factor. Now, the downside to what we're trying to, I won't call it a downside, but the challenge to this one is that you need to have a subscription, because the GSM, the LTE network it uses, I think this one is based in for North America. Yeah, and then some part of how do you call it? Some part of Africa. Yeah. But the thing is that what's happening, it's fully serviced, has over the configuration, firmware upgrades, all that built into one piece. But the only thing is that you need to have a subscription. All right, so it's subscription based, and they have already a platform, and you can track all your things from different places in the world. Now, that is kind of like the solution we're going for. All right, so we're trying to build a similar solution from scratch. So bear in mind that the form factor might not be as small as we want, but if we design it, we could actually send it out for printing in a very small form factor with smaller sensor form factors. All right, so all the sensors we're using, they're very small form factors that can be used. All right, so just bear that in mind. So I just wanted to make you aware of this as well, in addition to the Estimote LET one, which I showed you the last time. So this another variant that we could use. So if we go back to the dashboard very briefly, so here, this was supposed to have been the off-shelf solution that we wanted to use, which is the Estimote. If you want me to do kind of like a video on this, a review on this, setting it up and using it, give me just put it in a comment, and I'll do a video on how to use this and setting this up. All right. So, well, now that we know we're not using this, it's time to say adios to this one. We can pack this somewhere else. Okay, now let's get back to this. So now, the idea is, since we're going to be building from scratch, okay, then we're going to be using one of these tools, one of these, sets here. So let's walk through the process of, picking the best. Let's go through the process of picking the best, and then we can use that. All right. So first off, in terms of the boards, all right, let me bring this here so I can get everything that I'm talking about in view. Awesome. All right. So in terms of the board, again, I was saying that let's be aware that because we are not, the form factor now shouldn't be a big deal, like shouldn't be a deal breaker for us. The form factor shouldn't be a deal breaker. So we can actually go for this. Let me do this quickly so I can track and monitor this. I'm trying to get. I try as much as possible to monitor this to see how it's doing on the other side, so that wouldn't have any challenges when people connect. So let's see. Let's go here. Let's check this out. Yep. So I'm just gonna put this here, as it is, and then we can see how this is going. All right. I don't know if this. Okay, cool. All right, so it seems we're cool now. So I'm just gonna leave this there right now. Okay, so let's get back to it. Now let's, like I mentioned, the form factor will not be a big deal at this point because we're trying to build from scratch, and then we can, minify it, and we know how to build it, and then later on we can minify and do whatever stuff we want to do. So my choice of, the boards, all right, would be first off, I have the Arduino Mac 100. I mean, it's still trying to, keep to that small form factor. All right, so this is how the Arduino Mac 100 looks like. All right, kind of like very small. And I'm saying if you're going to put this in ballot boxes, you want something of a very small form factor, that you can easily, fix and do that. So this is on for consideration. Now the only drawback to this is that this is not internet ready or web enabled, so to speak. So I wouldn't be able to talk to this in any which ways. All right. So I'm looking for one with a service that allows me to talk to it or to remotely, connect to it. Now, that will mean that you're looking for a board that has the ability, and then don't forget that you're trying to look at something that's going to be in the field. So something that potentially has the ability to do like, LTE or 3G, 4G, whatever that is. All right. Now, so if that is a key thing to, that we are going off of, then that means that we can consider the particle boron. This is how it looks like. It's from Particle. Yeah, the same company I just showed you that does that actually has a product out now. So this particle boron is actually an LTE compatible device. So and if I show you at the back here, so if you look closely down here, let me turn it this way so you can see it. At this side, this is where you can put your micro or nano SIM, one of the SIM. So this is where the SIM goes. All right. So when you connect this, now it means that this can be reached and communicated with over a network. All right. In the same way, it would have the capabilities to also send out stuff. Now, one of the solutions or options would have been to actually consider having something like a LoRa or a Sigfox network. All right. And this, I'm calling out my my senior or my manager from work, Gulam. He actually suggested that, have you considered using Sigfox or one of these low powered WAN networks? And I was like, yeah, that's actually a good idea. So, but unfortunately, we don't have Sigfox networks here. So that would have been cool if we had a Sigfox or LoRa network. Then we could build one of those Sigfox or LoRa compatible devices and not worry so much about connectivity. But now, in terms of connectivity, this here, the particle boron, is the one that seems to be like a contender. So this is what I want us to start with. The first thing is to understand how to build it, and I would want us to use a very common board, because not everybody might have access to the particle boron. All right, not everybody might have access to it. So I would want us to try and look at a very common board, which in our case would be the Arduino. All right. Yes, Arduino at this point doesn't have any connectivity and all that. So, but the only thing is that I want to start off again, just like we did the home environment, monitoring. We can start with learning how to connect, the GPS, the Gprs sensor, connecting the magnetic switch, and then I've added a buzzer just, for taste. And then, yeah, pretty much that is it. So here's the options we have. And then here we go. The accelerometer, 6-axis accelerometer, which I've added here. So the idea would be to probably try to assemble and connect everything now using one of these boards. So now it is between the boron, all right, and the Arduino. So the boron, we can have connectivity using LTE. Now, at this point, I don't have a SIM card, so I won't be able to set this up now, but tomorrow I'll go out and get a SIM card, and then maybe in the next episode we'll set it up. Now, so it's clear now the winner is between the Arduino Uno, just for learning how to do it. And if we want to do a proof of concept, it will be done with the boron, the particle boron. All right. So I can also throw the nano here. Now, with all this set now, so between the um, Arduino and the particle. Now, because for the particle, I also don't have a SIM card now, I will defer for today and then we'll just kickstart it with the Arduino. We can always transfer code and make the changes in subsequent episode. Now, and also because the sensor we are using, all right, if you look closely, this GPRS one, yeah, the GPS. So this GPS sensor here is actually of a groove. It's a groove type. So we can see the JTAG. Let me break this here. You can see the JTAG connectors. Please focus. Yeah, there you go. And this is the antenna. All right. So you can see the JTAG connector here. So that's what I'm going for. And then also, we're just adding. Where's the buzzer? Where's the buzzer? Yeah. So we're just adding a buzzer, just for just for like visualization stuff. Right. Okay. Now, unfortunately, we don't have how do you call it? We don't have a groove compatible magnetic switch here. That is another reason why for now I want to go with that with Arduino, so I can also connect that separately on the board. I can do that also with the particle shield. Like I can put the particle shield, like instead of using the how do you call it, the groove shield for the particle mesh, I could just put it on a breadboard like this and then wire it per the pin. Like I can put it on a breadboard like this and then just wire it by the pins, to the service and not use this. But when we do that, I won't be able to connect this because this is the only GPRS module that I have, and this one is JTAG. So that's why. So that's why we're not doing this now. But we're going to be interchanging between the two as we move on. So for today, and here's how you connect it. So I would have connected the particle mesh. Would have been connected this way. I hope I'm not missing any. Yep. So would have been connected this way here. All right. On the shield. There you go. And then now it will be as easy as picking, the JTAG, connecting it here. There you go. All right. And then you connect it to any device, any sensor, and then you can program it. All right. So that would be how easy you do that. All right. But because we're not using it, I'll just connect it this way, and then we'll put it here. And let me bring this in view. So there you go. So for today, or for the rest of the episode, we'll be using our Arduino. This is our Arduino, and then we have a shield. So this is our Arduino Uno, any compatible Arduino Uno, and then we have the shield that allows us to connect extra stuff as well, in addition to how do you call it, the groove kit. So let's go ahead and connect it. Let me make sure I connect this properly. I always have I broke one of the pins on my other Arduino, so it's made me a bit yeah, there you go. All right, so we have our Arduino connected, and where did I put that Arduino? Oh, now I hate this. Where is that? This is crazy. Okay, so now we have our Arduino, and for this one, let's see this. So I might have to maybe try to solder a jumper cable to it, but for today's episode, I won't worry so much of the magnetic switch. We'll first start off with connecting the GPRS module. All right, that'll be our first point. So today we can put the switch here, and then we'll just leave the 6-axis accelerometer also here, and then we can pick it up from there. So maybe if we can connect these two, basically, for now, just the GPS sensor. So today's episode, we will be connecting the GPS sensor to the Arduino, read some data, and have some fun. So what do we need prerequisite? I have the JTAG cable. I have the GPS module. So I'm going to connect it. There you go. So I have this connected. All right. And then now, let's go ahead and then go into our Arduino IDE to set the rest of the things up. All right, cool. So if you're joining us from Facebook, from all the other networks or all the other social streams, welcome. We have started building the ballot box tracking system, and today we're starting with connecting the GPS sensor so we can get the GPS location of the ballot box, and we are going off of the um, Arduino Uno and then a seed shield. All right, so let's get into it. So let me actually get rid of this. We don't need this now. Let's go back to the desk. All right, so let's go all the way to, let's look for this. All right, so always remember use the data sheet from the provider. All right, so let's go to Seed Studio. There we go. And then, yes, and then also, I mean, this is not a paid advert, but these are like cool stuff that, if you can get your hands on the Wheel terminal, awesome packed with stuff. I'm hoping to get my hands on one pretty soon. And then once I have it, I'll probably do like a full video on using it and connecting. So stay tuned. So let's go ahead and look for GPS. And let's see. Yep, this is it. This is it. So let's look at it. We also released new Groove GPS Air 30. Let's see, is it Air 30? This is just 1.2. Let's see if it's I think it's this one. I think it's this one. So feature. So let's look at this. Sorry for the big size because I've zoomed in. Is it the same thing? No, this one. Hold on. This one is the same 28. So I don't. It's not this one. Let's see. Yeah, I think this is it. Yeah. It's this one. Yep, SIM 28. Yep, so group GPS model. So if you were looking at purchasing one of these from Seed Studio, it is $23.50. So do the math, and basically, this is how it looks. The same thing we have here. I can actually flip that for you to see, but this is it. Same one we have with seen on the bench. So let's get into it. So now, so let's go. Says that we also released it. So there's a new one which has a higher performance, high integrated multi-mode satellite positioning. Let's look at that. Let's check that one out. Let's check it out. Oh, okay. So Air 30. So and surprisingly, it's cheaper. So if this is high performance, high integrated multi-mode satellite positioning, and I'm guessing we're supporting plenty of locations such as GPS, Beirut, Galileo, and all that, and it's cheaper. Well, that tells you that. I mean, and I think this here. Let's see. Feature supports NMIA and new block 6 protocols, low power consumption, baud rates configurable, Groove UART interface, both compatible with Arduino and Raspberry Pi. All right. So we're just trying to understand the fact sheet for our module. All right. So if you put your Raspberry Pi on in a while, or Arduino in the wild, can you track its location? Well, this can make it happen. So let's see. Basically, cellular technology. Well, this is like giving us, rundown of what the cellular technology. That's not what I'm, worried about. So have a baud rate 9600 and 11152. That's fine. 22 tracking, 66 channels. That's cool. There's an antenna included, as you can see. So this is like this side is the antenna part that you're seeing. Another thing would be integrated. You would want a way to have like how do you like an antenna that is probably on board but still high accuracy, so that because you don't want antennas hanging over when you position and when you fix it. Right, that's another thing. Not that it matters, but then I mean in production you would want to alleviate that from it. So let's see. All right, let's see if we can move to a different Bear with me. I'm just trying to get into a different platform so I can also track that from here. So let's see. Okay. Let's see where the magic is. Yeah, that would have been, that would have been very, very strange, but that's working. All right. So, Groove Base had Raspberry Pi base. So these are like the expansion boards that it can use. All right. So let's see. So Groove GPS, there's a wiki for it here, which gives us all the information. And this actually is like examples of solutions that have been built with it. So let's look for this, getting started. It should give us a documentation. So we're using the Arduino Uno. All right. So, yep, default 3.3 volt, 3.3 and 5 volts compatible. So that's fine. So there you go. Yep. So now let's go ahead. So platform supported Arduino Raspberry Pi. So getting started. So we are using so this is, as you can see, the three things. We have it here. All right. So step one, the start below, which is your Arduino. We have the Arduino. Let me actually go back to the bench so you can see this. So we have the Arduino and the base shield on top. We have the sensor, all right, here, which is prepped and ready to go, as you can see. All right. And yeah, so basically what we need to do now is we need to connect it to digital pin 2, D2. All right. So let's go here. So I've added a JTAG to it at this point. Yes, I know I'm going to be beaming my location to people to show them where I am. But and then if you look closely, so if you look on the board, let me turn it this way. All right. So you have D4. Let me bring it here. Usually I can use my finger for it to autofocus. Focus, baby. All right. So we have D4 here, we have D3, and then we have D2 here. There you go. And then we have D2 here. All right. So I'm going to connect it to this one, D2. All right. So let's go ahead and D2, D4. Yeah. Cool. So now we have this connected. And let's see. Actually, let's go back to the fact sheet and look at it says up to, is it 10 meters? Let's see the accuracy. Schematics. No, we don't need the schematics. Let's go here. I'm trying to look at them. It showed us the accuracy rates. Accuracy here. Okay, so 2.5 meters GPS horizontal position accuracy. And then what is it saying? Oh, so they are comparing it with. So this is what I'm looking at. Just so I don't confuse you guys. So I was just looking at. So this is the. Let's do this. Yeah. So this one, the one on the left, is what we are using now, and the one on the right is actually compared to the new one that you're talking about. All right. And if you look here, if you look at so it takes cold start has 13 seconds. So okay, warm start 1 to 2 seconds when it's using hot start less than a second. That's cool. Now, so look at the accuracy here. So it's like 2.5 meters GPS horizontal position accurate. All right, accuracy. Sorry. So, all right. So now we've connected it the way it is, and so as you can see, 5 volts ground, D3 white, D2 yellow. But in this case, we have 4. Yeah, so it's connected to it. All right. Now, view center. Have I used this tool before? Yes. So why didn't They want us to use this. Yeah, yep. So, so this is kind of like, for visualizing, um, visualizing it, all right, with the position, because you can get the data from the module, but visualizing it will need, like a tool like this to do that. Okay, so let's open our Arduino ID. Where's that? Where's Arduino ID? Not the app. Not the app. Not the app. Not the app. Actually, you know what? Let me open this and see where. I mean, yeah, I don't need the app. The app usually misbehaves. So, Mm-mm. Okay, before that, let me quickly. Let's see. Use center for. Yep. Allow it. And good thing this time around, I disabled antivirus, so I don't have any, blocking issues. Yep. Accept the cookies. We don't want to do this. So use center for Windows. Yeah. Yeah, that's what I need. Installing. Yeah, let's put it on the desktop and then just go get that installed. There's actually a Bluetooth version of it. Okay. So let's see. This is done. So let me extract it here. So yeah, the reason why I like to do this on put in this for that. The reason I like to do this live is that so I can walk you through that process. All right. So you know that hey, it's someone um is not doing any magic, right? Okay, so this looks like a processing file. Yeah, if you don't know processing is like is a tool that allows you to use connect um interactions to IoT stuff, or like it's like it's a tool that bridges physical interactions with modules and technology. So something like light, how you transfer sensor values to control light and all that, like in a very physical interactive way. People have used it to do a lot of art shows, and yeah, so that's something cool that you can check out. Okay, let's see. Let's see. Um, well, I'll just check this and try to install it. Let's install it. I know it's going to be processing. Okay. U block. Yes. Yep. All the drivers. Yes. Okay. We have that installed. I can close it. Updates available for some libraries. All right. There we go. We have our uBlock GNSS evaluation software. We have it. And yep, this is where I need Sienna to help me understand all this craziness. I'm not a GNSS expert, so Sienna, if you are watching or if you watch, please connect and help me later. All right, so we have this done. We have our Arduino. Let me open a new one. This is a sketch for the hands-free thing. So let's do a new sketch. We can forget about this one. There you go. Let's go back to, so we have this installed. At this point, we don't need this. Let's not burden our system with a lot of. So this is the wiki. So this is kind of like the same thing that we are looking at now. So we don't need this. All right, cool. Let's take it from here. All right. So now, we need to upload this code. Well, let's copy this and go through it so we understand that we're not just doing copy and paste. All right. There's some. So there you go. So we have software serial that allows us to do serial communication with the device. So we're setting the pins to pins 2 and 3. If you look at even though we're using D2, you see that we're using D2, but then it's picking pins 2 and 3 on the board. So that's it. So obviously we have our setup. Oh, let me just actually undo this so we can make this look appealing. Yeah, so let's also separate the include. So we have our include file. Let me actually save this into Arduino. Let's go back here. Let's go save it somewhere that we would remember. dev. Where is the Arduino? I think I created. Is it Yep, IoT. And then let me create a new folder here and call it Ballot box. And then we can save it here as Ballot box. Right? So we have the sketch done here. So remember the baud rate from the data sheet. This is the baud rate for reading it. So we set it up already. We're beginning to read this, and then so while there's data available, if there's data coming in from the software serial ports, that is data is coming in from the shield. Let's read it. So we're getting the data into an array, and then we're writing that data and we're displaying it. Now, if there's no transmission, we end with a buffer to the hardware serial port. Yeah, so pretty much that's how we're setting it up, right? So we're calling software serial that available that reads the data coming in, and then we're storing it in an array and then outputting it. So here, there's a function to clear the buffer because you don't want to overload the buffer and then cause any crazy issues with your system. So let's go ahead. Let's check now. Before we do this, where is the Arduino connection? Hold on, let's see. So I was just sitting here and I was just connecting, and I was like, wait a minute, where is your? Oh man. Okay. It was here somewhere. Okay, not this. This is crazy. Okay, I have another one here. I guess I'll just pick that one. Where did Samuel put that? Where did Samuel put that? And I thought I had just put it on my desk. Oh man. Only to realize that I hadn't put it on the desk. Now, so it's just a regular how do you call it? Just a regular printer USB, so to speak, so to make it much easier for you guys to discern. I have a few of them lying here, so I'll just go pick one from my oh yeah. So happy day. Yep. There you go. You never find it when you're really in a hurry looking for it. And then just after it just jumps in your face and says, "Hey, here I am. You're looking for me. Did you find me?" What is this? Oh man. Okay, let's see. This should have been here. Okay, yeah, it was right here all along, right in my face. Oh man. Awesome. Let's go back here. Which one do I use? Yep. There you go. So let's go ahead. Let's come here so I can. So let me make sure I'm connecting this to the right thing here. Yeah. And now let's connect this over here to our computer. Yep. I can hear the sound. It's connected. If you look closely, we have lights. It's a good thing when you see light. So we have light. I hope you can see them. We have lights here. You can see a green light here and a green light here. Right. Cool. So with this connected, let's. So because we have the code in. All right. So let's go ahead. Let's go ahead. Let's go ahead. Let's go ahead. So what's happening is it's reading the information, sending it to, because we have a USB connected to this computer, it's also opening the serial port and pushing the information to the serial port. The serial monitor. Now, because the data is being pushed to the serial monitor, it's going to give access to the UCAS application to read the data coming from the serial monitor and then displaying it in whatever visualization. So let's first of all, when you connect, make sure that your board is connected. So we have Arduino Uno COM10, which we use for this, and it's an Arduino Uno. Make sure you are connecting it to the correct board. Else you're going to have some misbehavior. So let's check this to make sure the code is good. And if you look right above my head in the bottom corner, bottom right there, you see there's a green progress bar telling you, well, yeah, all is well. So I can go ahead and then upload. And then the skill or the sketch should have been uploaded now to this Arduino Uno. All right, so with that done, what are we supposed to do? So now let's open uCenter, which we have opened right here. All right, for now, I'm just going to push it here. And then once it starts running, I'll bring it in view for you to see that. And then let's click the receiver and then port and select the COM port that Arduino is using, which is COM port 10. So let me zoom this for you so you can see this properly. Now, this is just for you to read the data coming in. Once you have the data coming in, you can interface in your application in any which ways. All right. So let's go to receiver. And then where is that? Connection. So it's on COM port 10. So this one actually it's changed a little bit. So here saying we should go to receiver and then port. But if I bring this in view for you to see, this is actually receiver, and then you can see connection, and then I can pick COM port 10. All right, here. So let me just bring it back here. When I'm done with it, I'll bring it. Okay, so let's do this. It looks like something is coming in. It looks like something is coming in. What is this? Okay. So click the receiver baud rate and make sure we have, so the same thing. Baud rate is 96, 9600 connected. So let me show you this. This is what it's saying. So again, how can I make, okay, this is not. So receiver baud rate 9600 and then receiver connection COM port 10. What am I saying? All right, let's move this here. And then, so click view. There you go. And then let's see text console. Where is that? Oh yeah, I see the text console here. Yep, awesome. We can also make this big and then bring this a bit here. All right, so now open the serial monitor and we can see that information. So let's go to our Arduino IDE and go to tools. Where is our serial monitor? So we open that. Oh, yeah. So realize that, see down here, port is busy because the application is using the port. So this is what's happening right now. So this is data. This is data coming from the Gprs thing right now. So I don't know if you can see that. So I'm just moving around. Now this is 2.5 meters. So you might not see a large difference. Okay, you might not see a large difference from this. You'll probably see a lot of difference if, let's say, if this were, let's say, in the field somewhere. So that's what I'm saying, that ideally what will happen is eventually I'll use a particle board and then have this connected to it, and then I can just put this like in a box. And because this is GSM, I can let the particle be sending data, and then we can read the data, interpret it how we want. But right now, as you can see, we have data coming in, and this is from this GPS module right now, right? So data is coming in, all right? So let's bring this here. All right. So yeah, it's streaming. Let's see. So if you look closely, so it gives us the north and east and all that. So I'm trying to like pick that out from the information we're seeing here. Um, GPCC. So that's the GPCC. Yep. Where's that? GCA. So let's bring this here. It's okay. Let me see. Let me see if I can bring zoom it in. No, not zoom. Yep. Let's open zoom it so that I can use that to give you a bigger look. All right. So where is that? Let's see if we can find that out. So it also takes a few, a few seconds for it to warm up and locate the satellite. And maybe because I'm also indoors, um, it's taking a bit to get. So I'm just trying to find where that is. So we should see the coordinates in there. Yep, there we go here. So I'm tempted because of the cable, but I'm tempted to just try to just move this around some way somehow. Okay, sorry. So if you look closely, I'm just moving. Uh-oh, I disconnected it. I actually disconnected when I picked it up. The USB connection messed up. But hey, yeah, because we already have, the sketch on the Uno, it's still streaming the data. So yeah, so now this is bringing the data. Just wait for it to, you know, get the positioning so I can yeah, so GP, what's that? Yeah, so we're getting the info, heading, the degree. So this is just time. Let's see. Yeah, it's still connected. I think because I am indoors, it's let's see. Let me see if I can just mess around the receiver bit and see. Okay. Yeah. Yep. It's a lot of data in there. Um, I don't know anything about satellite, so I can't, but then I'm going to look that up to see. But at least there should be one with headings, like with bearings. Okay, G2 connected to G2. Actually, let's do this right here. GPS G2. What is that? Let's come back here and let's look at this. Oh yeah, we also can view data in Google Earth. That is more like it. I mean, if we can see the information in Google Earth, that's more like it. But let me see. Let's just for curiosity's sakes and for learning, GPS G2. Let's quickly Google this. Let's see. GPS G2. What's that? What did I type? I said GPS GS2. So GPS G2. Okay. What is this? GPS2. Hummingbird and operating system features. Okay, so it's probably something along the GPS line. That's fine. That doesn't interest me. Now let's see if we can use or if we can get this from. Let me actually put this here, so you can, if you have a Raspberry Pi or if you have the Uno and want to try it out, that would be the link for you. So let's try Google it. So click File, Database, Export. All right. So let's do that. Let's see this. Then okay. So let's try this. So let's go to File, Database, Export, Google Earth KML. So let's open this. Yeah, that's a lot of information. So let's go to File, Database Export. Yeah, Google Earth. Okay, there's actually Google Map HTML, and there's also Google Earth KML. So let's do the Google Earth KML. here. Okay, and let me put it right here on the desktop. Yeah, let's save this. No, I don't open the created file. And let me try this as well. Export, and let's do Google Map HTML. And I'll just put it also on the desktop. Okay, let's see. Moment of truth. Let's open this in Edge. Let's see what data this generated. So I didn't do anything special. It exported it as oh yeah. I'll need to provide I'll need to go into the file, change it, provide development, what. No, so we don't want this file. Okay, so let's see. Let's see. Okay. Okay, then we can use a launch Google Earth with the history that was captured by use entertainment data can be recorded pressing the red circle on the toolbar, which will ask you what you want to save. When you have captured enough data, click the black square, stop recording. We can then convert the USB file generated to KML. Using upload file to visualizer. So I think what's happening is that this is generating a UBX file, but if I look at the file that has been generated, it's still KML. All right. So let's try this again. I'll just do the KML export, and then when it asks me to open it, I'll just open it. All right. So I think that I think Seed Studio would have to how do you call it? Would have to update their steps because it's a bit different from here. Okay, let's see. So let's see. Launch Google Earth. Let's see if I can get. I don't have Google Earth. Yeah, desktop version of Google Earth. Uh, Classic desktop Earth must be downloaded and installed on Windows, Mac, blah blah blah. Okay, so let's say, yeah, let's do Google Earth download. For the sakes of this, would have to add what? Add versions. Google. Okay, well, maybe. Okay, so Google Earth. Oh, this is get on mobile. Google Earth Pro on. Yes, I want it on desktop. Yeah, that's what I want. Download Earth Pro for desktop. I hope I'm not have to. I hope I'm not paying anything. I'm not going to help Google do anything for now. We just want to have the software. Thank you for. Okay, desktop. And it's just to. This is one reason why I wanted to do the GPS first, because that can take a while. So upload a GPS file, choose an output. Okay, so let me see. Upload this on the desktop. Let's see if so. What was it? It was KML, right? So if I copy this, open this, and then it says that I want, let's say, Google Maps, right? And then I map it. Let's see what happens. Actually, let me give you Google Map waiting. Google Map. Okay, where's the data? Where's the data? So there you go. We need to have a Google Map API key. All right. I have an API key somewhere. Um, let's see if let's try something that will not require us to have like any. So let's choose the same file again. Let's pick the KML file and let's just use PNG map. Okay, let's try Google. Let's try this first. If we try the Google Earth and that also doesn't work, we've not installed it. We've not installed Google Earth, so this will not. I hope it doesn't know. I hope it doesn't. Okay, let's just stick to. Well, if let's see. Okay, whilst we're doing that, I'll just go ahead and install it. All right, and then I can try. I'm going to try again, but this time I'm just going to pick like a PNG map. Let's map it so we can see it. Um, well, whilst doing that, let me go open my console and get my Google map. I have a key, so created by GPS Realizer. But look at that, just track. So like there's nothing in here. So this is why, okay, you know what? Let's go with the second option of actually recording a lot of data. So I'm going to open, sorry, you're going to see a blank screen because the installation is requesting for something. Okay, now it looks like now data is coming in. Okay, I'm going to hit the record. All right, and okay, you let me just make it UBX now and just save it on the desktop. And just I'm just gonna allow it to. And the log file must contain the configuration for GNS receiver. Do you want to pull install? Yeah, just leave it. Okay, so allow it to run, get some information. And disclaimer, I don't understand any of this satellite information, but I'll look it up and ask friends who do that. So they will probably help me like make meaning of this. In the meantime, I'm going off the second option where I can click the record button on this one, okay, get enough data, export it, and then I can now use that data and open it in any of this, third-party things. Because it looks like the data that I'm exporting now isn't enough to show me stuff. So let me look for APIs. APIs. Go to my APIs. I need a Google Map API. I've actually opened my Google console, Google Cloud Platform console on the side, and I'm trying to get my Google Maps API. At the same time, too, we're just waiting for this to get enough data. Okay, so it looks like we have Google Earth. Google Earth. We have it downloaded. All right. So I'm going to put this on the side as well. Okay, so let's see. We're still recording. Okay, installation is complete. Where's that? Let's open it. So, okay, so this is in the UBX file format. So let's take a look at what they said for the UBX file format. So they mentioned that when you have captured enough data, click on the square to stop recording. You can convert the UBS file generated here by using the uploaded UBX file into this. So they're saying that with a UBX file that will generate, all right, we can upload it also in the same endpoint to get the map information. All right. So let's see. Do we have enough data? Oh, so blocks of data coming in. I see some. Okay. Oh, now I think I see. Yeah. Okay. Now I see some east something. Okay. So hopefully we're still recording. We're still recording. So it's technically going to be like in one place. So let's go ahead and stop the recording. Where is that? Where is that? Okay. And then we can hit record. Yeah. I will just probably say test. Yep. Okay. So I'll just wait for this to run a few times so that I can Okay, so that looks like the satellite position G. Now I see G24. So it looks like that's like tracking the satellite positions and telling us where we are based on those positions. So if you can look, so this tells us what the thing will be to take all this junk right now, right? To take what looks like junk and then translate it to it is latitude, longitude. So that's what I would do. So we are top of the hour. So I'll do that offline and share that. But before we go offline, at least I want to be able to export this so we can see what it means in one of the editors. So spare me, like bear with me for a few more minutes, or yeah, not too much time, just to have this run a bit to this side so I can have capture enough data to show you what's happening. Right? Let's see. Okay, so the first one is still running here. Ah, so this is the first one. Interesting. Yeah, so that's like captured a lot of. Okay, there looks like some retrying. I see a lot of retrying. Timeout occurred without receiving an answer, so I can abort this. And let's see, window. Okay, so yeah, let's look at the test console. Yeah, so the text console is giving me data. Okay, so I can now go to, let's see if I can select all and then file, export to another KML, and I'll call this one test dot, is it what? Yeah, we'll just call it test. And yes, and look at this. So it, when I said open it, it actually automatically went ahead and opened it um with a Google Earth automatically. I didn't have to do anything. So let's see. Ah, interesting. Oh, where is that track? So when I selected it, exported from center, so track. So where is it? This thing is making me impatient. Okay, let's go here. There you are. Let's see. Okay, let me go to file and then open. And let's see. Okay, KML. So let's go to the desktop. And let's go, there isn't enough information. So it's on 1.74. So I'm just feeling it probably hasn't captured enough data. Yeah, it's the same thing. No absolute. So it looks like I'd have to leave this to run for a long time to get some tracking data. And it also looks like because it's just in one position. So hey, let's see. Yep. Boop, 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 boop. Yeah. All right. So I'm going to leave this to run for a while. Let's look at the window. Let's see this one. Well, this one I've already killed it, so I'm not worried about this. So this is still running. Window. Let's look at test. Test is not done anything. So okay, 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 okay. That's the baud rate. We are connected, as you can see, COM port 10. Let's see this. All right. Okay, so I'll just leave this to run for a while, and then when I get enough data, I'll try to export it to show you how that panned out. So that is the end of the very first, the second actually series, the second episode of the series. So in next episode, we're going to connect the 6-axis accelerometer and gyroscope and all that. So that's what we'll do in the next episode. So till I come your way again next week with the continuation of this. Be safe, be good. Let's learn something. Reach out to me if you have any questions on all my social media platforms. I'll try as much as possible to answer them for you. Till then, adios. Have a wonderful time and be safe.